Hello, everyone, and thank you for joining us today for this HashiCorp webinar, where today we'll be exploring zero trust security for retail. My name is Connor Beechinor. I'll be your moderator for this session, and today I'm delighted to welcome both Russ Parslow and Lucy Davenhart, who are both on our solutions engineering team here at HashiCorp, and they'll be your speakers today. In terms of the agenda, we'll start with a quick overview of HashiCorp, who we are and what we do, before exploring the current industry landscape, the challenges that you're facing, and how you can ultimately then implement a zero trust strategy. We'll wrap up with a live Q&A, so if you do have any questions, please post them in the chat at the bottom of your screen and we'll answer them at the end. Please note that this webinar is being recorded and we'll send that out to you via email after it's been processed, usually within the next 24 hours. So with that, let's get started. Over to you, Russ.
Awesome. Thank you so much, Connor. And hi, everybody. Welcome to the webinar today. Really pleased to be speaking to you. So I'm Russ Parslow. I'm a solution engineer, as Connor mentioned. I'm based in a very cold but crisp and pleasant London here this afternoon. So one of the things that I found, I've been at HashiCorp for a number of years now, and certainly in the early days, perhaps less so now, was I would talk and I'd say, hi, I'm Russ from HashiCorp, and people would say, what's a HashiCorp? Never heard of them. And then I'd start to mention some of our products, and then people would go, oh, of course I've heard of your products. We're using it absolutely everywhere. So just wanted to touch on a little bit quickly about who HashiCorp is, in case there are still some people who haven't heard of us. So we are a company that provides software across sort of 4 areas for provisioning, secure, connect, and running of your applications. Regardless of where those applications are actually running, it could be an on-prem environment, it could be in the cloud. Most commonly, it's a hybrid across both of those different environments. We celebrated our 10th anniversary at HashiCorp just last year, so we were founded in 2012. We had an IPO event in 2021, and I again personally have seen quite a huge amount of growth in terms of the number of people that have sort of worked that are working here now at HashiCorp. So we have over 2,300 employees, and I think that number is probably already out of date. We have several thousand customers as well. Maybe some people who are actually watching this now are customers of ours, and certainly people are using our products. So we have over 100 million sort of annual downloads. And again, I think that number is probably slightly out of date as well. I think it's slightly higher than that as well. Just in terms of some of the ways that we actually help customers. So when I speak to people, they are trying to develop this common operating model. As I mentioned, some people are running environments on premise, some are in the cloud, but quite commonly they have sort of a combination of both of those things. And one of the ways that they've actually able to sort of drive innovation is by having this common operating model across all of their different systems. And people typically have come from a private data center, but now you have that private data center and you're using AWS, Azure, GCP, etc. If we kind of just go through some of the layers in which we've seen that sort of dramatic change. We start at the bottom with sort of provisioning. Again, I was used to be a Windows Server engineer many years ago, it feels. Everything was run on dedicated hardware, dedicated servers. Whereas today, again, mostly thanks to the cloud providers that we have today, everything is very elastic on demand. And the way that we've kind of coped with that is by declaring what our infrastructure should look like using infrastructure as code. And people are probably familiar with that term, but basically this is what I want. And instead of using sort of the ClickOps method, as people have referred to it as, we actually describe this as code, and we use that code as our executable documentation, if you like, and that is what we are using to deploy all of our infrastructure today. And it's not just servers, for example, it's really any type of infrastructure you may be using to deploy your application. If we think more about the security layer at this point, again, everything was based on this idea of high trust. Everything inside of our data center was trusted, and everything bad was on the outside. So inside good, outside was bad. Everything was sort of IP based. So I used to know the IP addresses of all the servers that I used to manage, and that was how we manage sort of connectivity or trust inside of a data center. Whereas today, that paradigm probably never really worked, but it was all we had. Whereas today we have identity is our means to secure our applications communicating with each other, for example. So we're no longer reliant on the fact that we've built these strong 4 walls to protect our environment, because that paradigm doesn't really exist in the cloud and probably never really existed anyway. When I talk about the sort of the connect layer, again, it was very much host-based. Everything was very static again. So we controlled that through the use of perhaps firewalls. Maybe we use load balancers as well as a means of doing things like service discovery. But as again, we move towards the cloud, we're using a service-based approach. We know that the web application needs to talk to the database, for example. Those are services, and we use that kind of paradigm versus the old host-based or IP-based systems that we used to use perhaps in the past as well. Talking specifically about the products that we offer, I'm very fortunate. I get to talk about not just one product. I get to talk about 8 different products that we have here at HashiCorp. If we start on the left-hand side, and this is where people start to be like, oh, yes, of course, I've used Terraform before. I use it absolutely everywhere. Obviously, HashiCorp is the company behind Terraform, which we have on the left-hand side, which is sort of that provisioning component that can be used again everywhere. I've got some people who are using it really heavily to manage their on-prem virtualized environments, for example. Some people using it massively for the cloud. Again, everything in between that you can imagine. We also have Packer as well. Packer was one of the first tools that we actually created many years ago. And so it allows us to build those images, to have those kind of golden workflows in terms of the images that we actually deploy, all very much driven by this concept of infrastructure as code. So we've got workflow portability there because we appreciate that, there is no one size fits all, and people have workloads literally in every kind of combination of technology that you can imagine. In the networking space, we have Consul that I mentioned. So Consul is very much based on service networking, so service registry, service discovery, service mesh as well for people who are using things like a service mesh as well, but also a lot of the network infrastructure automation as well. I want to be able to automate the configuration of those firewalls and load balancers, but I want to use those systems as firewalls and load balancers, not as service registry and service discovery systems, because that's not what they were designed for. And again, wherever those workloads actually exist, we want to be able to connect them, because we can spin up workloads quickly is great. Unless we can actually connect it and people start getting value from those applications, not particularly worthwhile. Security. So in the security domain, we have Vault and Boundary, which Lucy's going to talk a bit more detail about later on in the webinar. But this is, with the idea where we have things like identity brokerage, where again, identity being the thing that we can use these days to secure communication between different systems, but also things like secrets management, encryption, and advanced data protection capabilities that we have inside of Vault. Boundary is really for, I as a user need access to a particular system. How can I do that in a way that scales particularly well, but is also secure as well, without having kind of brittle systems that are fairly inflexible or too coarse-grained? And then when we start talking about the very right-hand side, we have the application components here. So we'll have things that allow us, like Waypoint, for example, that allow us to have these kind of standardized workflows, regardless of what CI/CD, what workloads, where we actually run our workloads. We want a consistent approach to be able to deploy our applications, and we need to deploy those applications to somewhere. So we have Nomad, so we need to be able to schedule those workloads, make sure that they're healthy. When we have a number of instances of them running, if they fail, we need to restart them. All that kind of orchestration capabilities we have inside of there. Kind of the key, again, just to mention across all of our tools, is it's not just for the cloud. It's not just for on-prem. It's literally for pretty much anything you want. We're very much focused on workflows, not technology. So wherever it is you're running your application stacks, no doubt you're actually probably using some of these tools already. In terms of how we offer these tools to people, there are 2 ways we can do it. So we have the HashiCorp Cloud Platform. So this is our sort of it's where we manage the running of these applications for you. So we manage all the upgrades, the patching, the auto scaling, the logging, etc., and the monitoring. Or for those people who have a requirement to do so, we can actually also offer these products in a self-managed way. So you can install them inside of your own data centers and manage them yourselves as well. I think one of the things that we've seen, and probably everyone has heard this term, but certainly is the rise of the platform team. So all of our tools really are designed to enable the platform team to offer services and capabilities to the app dev teams as well, with a very, obviously the focus is on compliance, cost, agility, being dynamic, being elastic, kind of trying to remove some of those bottlenecks that that people typically have. We're trying to get rid of those to enable your app development teams to actually produce things that are going to provide value to your end consumers, to your customers. So that's sort of HashiCorp in a very quick nutshell. Hopefully people will have certainly heard about some of their tools, and hopefully many of you have now heard about HashiCorp specifically. So I'm going to move on a little bit now and talk about the retail sector specifically, and some of the sort of the challenges that I'm hearing from our customers who are working in the retail sector. And some of these things are going to be applicable to really to every sector, but these are sort of some of the things that they are actually focused on. So the first thing on the top of this list is something I think we're all subject to, is this is inflationary pricing. I think we're all very aware that the cost of living is increasing at an ever increasing rate as well. But the retail sector is obviously not immune from this either. So there's going to be an increase in the goods that they are then selling on to their customers, and obviously customers themselves are under pressure as well. People have been very cautious in terms of where it is and what they spend their income on. So they have this bit of a squeeze where the cost of things is going up, which means customers are a bit more conscientious in their spending, and therefore this kind of a squeeze from both sides. I think one of the things we've all sort of experienced over the last 2 or 3 years, there was a kind of a pretty much overnight, and it probably was overnight in some cases, this kind of shift to online shopping. So I think for the past sort of couple of years, many of us have, even if we've never used it before, and certainly if we have used it, we've started increasing our usage of it, is that kind of online spend as well. Now, fortunately, we've started to return to physical stores as well. So the bricks and mortar stores that were kind of sort of fairly dormant for perhaps a couple of years as well. So this produces some challenges. So, we had one particular model where we perhaps had physical stores with some online, to a big shift to pretty much the majority of things, sort of a lot of things actually moved to online. And now we've kind of really broadened it. We need to just cater for the physical stores that we have, also the online stores that we have. And certainly with online spending, again, it's kind of shot up. It's gone down a little bit now, but it's sort of stabilized at a higher level than, say, 3 years ago. And again, another thing that retail customers have said is obviously a huge concern is the sort of the rising costs of things like energy and wages as well. So that's something that they are very conscientious of. Some of the risks, some of the challenges that's actually causing is obviously with this rise in things like online shopping, some retailers have been ahead of the curve and been, having a very strong retail presence online for many, many years. In fact, some are only online, for example. But with that increase, there's obviously additional concerns that we have in terms of GDPR, protecting customer data. If we're transacting online, PCI DSS, for example, as well, has been hugely important, and making sure that we do all of the right things, while at the same time some of our systems start to creak at the seams perhaps a little bit as that number shot up. Another thing we've also seen over the past couple of years is this kind of huge rise in cyber attacks. Now, cyber attacks is always going to be on the increase. Unfortunately, that just is always going to be the trend. But I think the rate at which it has increased quite dramatically over the past couple of years as well. So there's been really there's always a focus on this, but an increased focus on protecting customer data as well, and making sure that all of the data is protected. Also, with all of these things that are sort of happening in the world economy, we're often seeing that projects are halted as of the sort of budget freezes have been quite common. So perhaps new projects or new infrastructure or new platforms that people were planning to build have been put on pause just for a little bit, just while there's some uncertainty in the world. What this does tend to mean is that perhaps the new project was to a new way to add a value stream to a customer. Because that's no longer happened, we take a look at our business as usual systems, and we need to make sure that they are working efficiently and they are working well, because those are the things that are going to continue to generate revenue. And all of that kind of comes down to that requirement to do more with less, unfortunately, with those squeezes that are happening. We don't want to switch everything off. We need to keep things running, but we need to make sure we do it in a cost-efficient manner. And then sort of finally, there's some of the goals. One of them is around convenience. So people now expect to have an online channel in the same way that they have a physical store that they can actually go and make their purchases from. So it's just making sure that with this digital channel is available, it's secure. People are looking for a consistent retail experience as well. So I don't really want to worry about whether I'm in store or whether I go onto my laptop and I order stuff from there. I want that kind of consistent experience as well. So how can retailers actually provide that kind of customer experience, or a different customer experience, to differentiate themselves from their competitors as well. With the potential that we still need to invest in our systems, but we're not going to do that because we're going to increase revenue. What customers are actually looking to do now is we still need to make those investments, but the way that we fund those investments is through savings in other areas of our organization. So people are very much doing this sort of save to invest. Maybe automation is one way that people could look to do that as well. We can actually save money through the use of automation, and then we can invest that money in other systems where we can provide additional revenue. Value to the customers as well. So again, people are becoming much more conscientious in terms of their spending. There isn't quite as much disposable income as there was. So people are really thinking about, well, do I really need to buy this? Do I really want this? So one of the things that retailers are always very focused on is how can they provide value to their customers. The more value that they can provide to the customers, the more likely it is that customer is actually going to spend the revenue with that particular retailer as well. And then sort of the last one, retailers, and it's probably not been true for some retailers for a while now, but some retailers would make decisions based on data perhaps a year in advance, or seasonal. We're all very familiar with sort of seasonal selling that takes place in the retail sector. So sometimes these decisions will be made quite in advance. Now, with uncertainty that's happening and the need to actually make a change in those decisions quite quickly, these need to be driven not through seasonality or an annual basis, but on sort of real-time data. So a lot of data decisions are being made, and this is what I've seen, an increase in the number of data platforms that customers are actually building and investing in, because they realize they need information from that system to make their decisions in order to operate their business. There's a couple of really good case studies. There's many case studies on our website I suggest take a look at. Specific to the retail sector, I think these are two names that most of us have heard of. Probably someone is maybe sat in a Starbucks watching this webinar at the moment. But Starbucks, for example, needed to secure their edge devices. And they, as you can imagine, are operating at massive scale. There is a store pretty much on every corner. So they needed to secure 100,000 of their retail edge devices. And they used HashiCorp Vault to actually secure all of those things. So if you bought a cup of coffee without realizing it, you will actually have used Vault in the background to help sort of secure that transaction. Decathlon, again, they went through this sort of digital transformation. They shifted away from being on-prem to all in on the cloud. They realized that the cloud was the best way for them to operate their business, and they had to go through this shift. So they're using Terraform Enterprise to be able to actually drive that innovation. And again, a lot of this comes down to efficiencies. We're going to talk about zero trust. Not only do we want to do things more efficiently, we want to do it quicker, we need to still make sure that everything is secure that we do as well. It's no good just going a lot faster and forgetting about making it secure. We need to do both in tandem, and it's possible. You can do both things. It's not a zero-sum game. You can go faster, and you can actually increase your security profile as well. So there's a couple of case studies, obviously a lot more detail on the website. I suggest you go and take a look at those. And with that, I am going to hand over to Lucy, who's going to talk about zero trust security. Thank you. Over to you, Lucy.
Thank you, Russ. So if I share my screen, you should all be able to see that. So yeah, zero trust security. So at a high level, zero trust security is this modern way of thinking about security that rejects traditional notions of trusted networks and systems and impenetrable perimeters. And the way I like to start thinking about this is from the presumption that an attacker is going to get into your network one way or another and may already be there. And if you start thinking about this from that perspective, it reframes the problem and then forces you to consider what solutions need to be in place to prevent that threat actor from elevating their permissions or pivoting to other systems. So, as Ross was saying earlier, sort of in the ancient times of like the early 2000s, it was a lot easier to think about how we'd secure our data centers. Everything was physical. You could see the physical servers, the network switches, and so on. If you are allowed within the perimeter, you may even be able to touch them. Russ was talking about you might even be able to memorize some of the IP addresses on some of the physical devices. It's a lot like sort of the metaphor we like using for this is that of a castle and a moat. So you got access for users and data is through single heavily guarded points of entry and exit. Unauthorized traffic simply not allowed in or restricted, and we kind of trusted the applications inside of our castle to talk to our databases freely. And in that model, there's this distinct hard binary between everything outside is bad, we don't trust it, and everything inside, yeah, it's fine, it's all good. And that's kind of a high school science way of categorizing things, which as we've matured as an industry, we know that that's not really how things work in the real world these days. And so if you try to adopt a common operating model like this, extending your infrastructure into modern data centers or into the cloud, securing based on clear fixed perimeters becomes a lot more challenging, maybe even impossible. So in the cloud, be it your own private cloud or a hybrid multi-public cloud environment, everything is dynamic and ephemeral. There is no clear perimeter. There are APIs for everything. The entire stack can be software defined, and infrastructure that was there this morning may be gone tomorrow. Entire networks can come up and down as required. And so if you don't have the ability to have this trusted perimeter, if you can't have trusted application mechanisms, securing your data can become a lot harder. And like I said at the beginning, you want to assume that you've already been breached and act accordingly. So I want to take a moment to consider what a cyber attack actually looks like. And whilst every attack is different, the attack structure is more often than not the same. And so what I've got here is sort of what we call the Mitre attack framework, which we're going to use to orient ourselves. And this is a shared language used by security professionals to describe security incidents. Attacks will flow from left to right. And whilst there are many more tactics than the ones I have here, these 5 are some of the most critical. Now, typically, an attack is going to start with some initial access. This may be an attacker compromising credentials, perhaps via malware injection, phishing, exploiting software vulnerabilities, or potentially just buying stolen credentials from the dark web. Once they are inside the network, though, they're going to try and escalate their permissions in order to access as many systems and repositories as possible. They'll scan the network for any file, or environment variable, or whatever, containing secrets, passwords, API keys, anything that could give them access to sensitive data. And they'll just move laterally across the network until they find something interesting, and they can then exfiltrate that. Now, traditional castle and moat security focuses on preventing that initial access, whereas zero trust is more of a set of principles aimed at reducing the risk of such an attack and potentially stop or slow down, at least, an attacker, even if they have gained initial access. And that's not to say preventing initial access isn't important. It is. It's just you don't want to rely on it. It doesn't want to be your only line of defense. And while there is no official definition of what zero trust means, there are 3 commonly agreed on principles around it. So these being the idea of you want to authenticate and authorize everything that happens. You want to assume that you've already been breached. And when granting access to things, you want to make use of the principle of least privilege. Basically, give people access to only the things they need access to, and only for as long as they need access to them. Now at HashiCorp, we translate these principles into the following set of imperatives. So identity-driven controls, mutually authenticated. It's not just a case of the client needs to trust the server also needs to trust the client. Everything needs to be explicitly authorized. So by default, you have access to nothing unless we let you have access. Access is time-based or usage-based. Perhaps you only need access to this thing for 5 minutes, or maybe you need one-off access to this, and once you've done it, you don't need that access anymore. Everything, of course, needs to be fully encrypted, and everything that happens needs to be auditable and logged. And so we define zero trust at HashiCorp as the implementation of these principles applied to how humans and machines access things and how they communicate with each other on the network. And so the place where we start with this is this idea of identity. So identity is much more complicated these days in terms of the number of clouds, tools, and a number of resources have proliferated. It makes it much harder to secure applications, networks, and users. And so the challenge when it comes to implementing a zero trust strategy is today we operate in this heterogeneous environment. We've got different computing platforms for infrastructure, different ways of architecting your machines. And so it becomes difficult to have a consolidated workflow across all of these environments. Now at HashiCorp, we are technology and platform agnostic. Our tools are designed to work the same way, whether you operate them in a VMware environment or in AWS or Azure, GCP, whether you use them in VMs or containers. And this really allows you to have a consolidated workflow across the board. And so let's look at how this affects connectivity for various different types of human and machine users. So we like to divide security controls into these 4 areas. So machine-to-machine authorization and authentication, and machine-to-machine access, human-to-machine access, and also the human auth as well. And the common denominator to get all of these right is this idea of identity. And this is the strong pillar by which you can implement a successful security strategy. Starting from the left, from machine-to-machine auth, regulates how systems get access to other systems. Like an application might need to consume data from another system, like a database. And if humans are in the loop for that process, to give that application access to the database, if you have humans doing the configuration, managing and protecting this credential handover, that can often lead to bad practices, such as credentials with long validity, secrets exposed in plain text, sensitive data not necessarily adequately protected, poor or non-existent auditing, and finally, because you've got humans who don't want to be doing this 24 hours a day, slow application onboarding. Now at HashiCorp, one of our tools is called Vault. And this is aimed at improving all the aspects of that machine-to-machine secret access. The way Vault works is it's a global identity broker. So it intermediates the authentication and authorization of secret exchanges, where a secret could be a database credential, an IAM service account, a TLS certificate, an API key, or perhaps even an encryption endpoint. But it allows you to have a unified and centralized auth layer in front of every sensitive system. And the way it works is it integrates with the most popular identity providers. So Active Directory, Okta, Kubernetes. There's a long list, and I'm not going to go through the whole list now. But this is done to authenticate apps and even humans using these existing identity providers. And once these clients have been authenticated, once they've proven to Vault that they are who they claim to be, Vault maps that identity onto a set of policies that define which secrets can or cannot be accessed and under what circumstances. And with this approach, there are a couple of main use cases where Vault gets adopted. So whilst you can use, of course, Vault to store static traditional secrets in its key value store, allowing operators to store and expose these static credentials to applications as needed. But you can also go one step further and have Vault actually generate credentials on demand. We call this dynamic secrets. Things like database credentials, for example. Vault can generate these ephemeral credentials for a number of different systems and then automatically revoke them after a certain period of time has expired. And that reduces secret sprawl and enhances auditability at every step, because every single secret that gets issued is logged and audited, is unique for every individual instance of an application that needs those secrets. And it's also a powerful encryption as a service platform. So customers like Adobe, for example, they use Vault to secure millions of transactions via what we call the transit and transform secret engines, the sort of encryption as a service functionality. And that allows customers to perform encryption operations without ever exposing the encryption keys outside of Vault. The second part of this zero trust story is around the networking. So we started off mentioning that the traditional castle model is not really consistent with modern cloud architecture. So Consul allows you to run a high level of network automation whilst adopting these zero trust principles we mentioned earlier. And all of this whilst operating in the same way across very different environments, on-prem, clouds, Kubernetes, VMs, wherever. One of the primary use cases for Consul is this idea of service discovery. So every new application or service can be automatically registered to the Consul cluster via Consul agents, and this process can be entirely automated. And that provides benefits when it comes to the discoverability of services and the monitoring of these services, as each of these nodes within a service is health checked by the Consul agent. And so individual instances of a particular service don't show up in the catalog if they're unhealthy. A second use case that builds on top of that is the idea of network security. And Consul provides you the ability to enable mutual TLS between different services that are connected to it, encrypting all the communications in transit between these services, and if you have Vault, nicely integrating with that for the certificate management side. And finally, because each of these services is identified by certificate, authorization policies can be used to do traffic shaping, reducing the potential pathways for communication that each service has to the bare minimum, in conformance with this idea of least privilege. So talking a bit about that integration with Vault, Vault can be used with Consul as a CA provider, certificate authority, and then based on that, Consul will create trusted connections between services. So Vault and Consul seamlessly integrate to thwart that lateral movement. Whenever a new service comes online, TLS certificate is needed to establish that connectivity with the rest of the mesh. And to establish and accept connection to and from other services, a mutual TLS connection is required, and that's accomplished through the client service verifying the destination service certificate against a public certificate authority. And once that connection handshake succeeds, all the communications encrypted and authorized. And finally, I know there are 4 bits to this. The third bit to this, the one that we actually handle, is the human to machine part. And this has become increasingly important, especially after the global pandemic, where companies have been catapulted into an all remote environment, and humans still need access to corporate systems. And traditionally, access to private resources has been implemented using VPNs, which are costly to manage, unsecure if managed badly, and can't really scale within modern infrastructure that we deal with today. So we have our tool called Boundary, which is a solution that allows you to tackle this problem in a slightly different way to how VPNs work. So the Boundary workflow is relatively simple. With Boundary, you want to provide strong authentication to end users, show them only the resources that they can access based on some authentication rules, some authorization rules even. And we want to be able to automatically discover the resources that they can access and then finally seamlessly connect to them using popular mechanisms like SSH, RDP, database connections, whatever. And before I explain how that works within the context of Boundary, I first want to compare it to how VPNs work. So with a VPN, your end user is sitting outside of your core network. They want access to, as an example, they want access to a database. And so first, they're going to need to connect to the VPN, and they'll have one set of credentials that they can use to do that. And that will give them access to some of the outer layers of your network. And it's possible, depending on what they need to access, that this might be sufficient network access to give them access to what they need. Usually that's not the case though. Usually the database server in this case is deeper within the network. And so they may need to SSH to a Bastion host, for example. And then from there, SSH to the database server or somewhere that has network access to the database server. And you can make that a bit easier for folks who do that sort of thing regularly. For example, you can put some magic in your SSH config file. I remember having to maintain some of that myself at my previous place. But as a general rule, the user has to know how to get to the database server in this case. And they also, when they get there, they're going to need some credentials to log into it to run their query. And so the way you can think about this is the user has to go to where the data is. And Boundary flips this idea around. It has it the other way around with the data coming to the user. So rather than connecting to the network and then diving deeper until you get to what you need, the user only makes a single connection to Boundary, which is running at the edge, and then Boundary handles the rest. So let's dive a little bit deeper into how that workflow works. So you log in to Boundary using an identity provider like Okta or Active Directory. These integrations allow Boundary to authenticate users, and it helps alleviate any friction that's associated with onboarding or offboarding. Because admin just makes changes in the IDP, and these are automatically reflected in Boundary. And you've got granular user auth for which systems the users can access based on the roles that they have. And admins benefit from Boundary's ability to automate the connection between the user and the host they're trying to get to by some sort of continuous service discovery and access configuration as workloads get deployed or updated. So when a user logs into Boundary, they're presented with a pre-selected list of all the applications and hosts that they have access to. And this dynamic host catalog can be populated automatically through service discovery, freeing admins from the manual overhead of constantly updating access lists. Or it can be configured using the Terraform provider, pulling in data from other systems as needed. But once a user has decided which target host they need to access, Boundary will proxy that connection between the user and the system that they're accessing. And here's where Boundary and Vault shine together. So the native integration with Vault means that the user gets passwordless access. So that means that Vault can automatically inject these just-in-time credentials into the Boundary connection to the user. And then the user never actually sees those. So I want to connect to the database. I never see those database credentials. I just connect to Boundary, and Boundary acts as this time-limited proxy to this private endpoint. And because I only have access to that one particular resource, I'm unable to access the rest of the network. And so taking a step back, it becomes clear how Boundary, Vault, and Consul enables organizations to reduce the attack surface through incorporating zero trust security. Each step in the way of an attacker's path, they'll encounter layered defense in depth to make the completion of their objectives as difficult as possible. So for the initial access, you'll need to compromise human identity to gain access. For example, you'd need to steal SSO credentials or bypass MFA. If you get inside, the next challenge is to find a token that can escalate your privileges. And thanks to the principle of least privilege, that should be very tricky. And even if you do find any credentials in files or in environment variables used by particular applications, because these are time limited or usage limited, by the time you try to use them, weeks, days, maybe even minutes later, they may no longer be valid. Lateral movement is becoming a lot more difficult because we're only allowing communication that's been explicitly permitted. And even if you are able to exfiltrate any data, because the encryption keys for that is stored safely within Vault, you've got no way to decrypt it. So we know the world of enterprise IT is complicated. And so to run these tools, you can run our software on the cloud of your choice, or let us run it for you on the HashiCorp Cloud Platform. With HCP, our site reliability engineers run the service, perform lifecycle management, and deliver against an SLA on your behalf. And it offers managed versions of Vault, Consul, and Boundary. And these decrease the time to get a secure multi-cloud for organizations by providing the most secure configurations for these tools out of the box on resilient infrastructure managed by teams of HashiCorp engineers, and simplified deployments so your teams can get started in a matter of clicks. Ultimately, we know security, and many of the things we've discussed in that last slide are fundamentals that are built into these solutions from day one. An interesting statistic is of all the companies that you might have seen in the news that have had massive data breaches, since they've had those data breaches, 80% of them then go on to become Vault customers. So we are helping them to avoid that ever happening again. So if you're interested in more about how we can help with zero trust security solutions and how we can help you solve some of these modern infrastructure challenges, I'm going to hand over to Connor, who's going to explain what the next steps are.
Fabulous. Thank you very much, Lucy, and to Russ as well. So as you can see on the screen, we have a couple of actions and ideally some next steps for you. So if you are based in the UK, in the London area, we have a Zero Trust Strategy Day taking place next Thursday, the 26th of January at Shangri-La at the Shard. So that will be a half-day event. We'll be joined by our field CTO, Sarah Poland, as well as guest speakers from Microsoft, which will further walk through how you can implement a zero trust strategy within your organization. The second call to action is that if you are managing a team of developers or practitioners and you want to have them enabled in terms of how to use the HashiCorp tools, whether it's Vault, Consul, Boundary, Terraform, any of the tools that we've spoken about today, you can book in a private hands-on workshop for you and your team to get enabled on those tools. And lastly, if you want to get started as quickly as possible with the HashiCorp toolset, then the best way to do that is through using the HashiCorp Cloud Platform, or HCP. All of those offerings available as a service, and as I say, is the quickest way to get hands-on with the HashiCorp tools. So with that, we'll now move on to the Q&A portion of the webinar. And we've had a couple come through from the live audience. So in terms of the first one, perhaps a question for you, Russ. What are the biggest challenges you are seeing with implementing a zero trust strategy today?
Oh, that is a great question. I think a lot of zero trust is actually, so zero trust, first of all, it's not something you buy. I know we've touched on the products and how we kind of enable zero trust, but zero trust isn't something that you would just go and purchase off the shelf. And it's like, I've bought the thing, I've bought the zero trust now. So really a lot of it is around changing that traditional mindset. We talked about that shift from the sort of the castle and moat approach that Lucy talked about, is that some of these paradigms, although we've actually had them for a while, it's around really kind of shifting that mentality to how can we, what does zero trust actually mean? You know, first of all, it exists. We have the capability to actually do it, and then it's a case of we actually implement it. So I say that's probably the hardest challenge is first of all realizing it's a workflow change, it's a paradigm change, it's a process change that you have to go through, and then obviously there are tools and there are capabilities, and Lucy touched on some of those today in terms of how you actually implement that strategy.
Fabulous. Thank you, Russ. And kind of leading on from that, perhaps, Lucy, a question for you. Transitioning to the zero trust model sounds like a lot of work. I'm wondering if companies hired people who have previous experience with Vault or zero trust models, or do you see teams learning everything for themselves and enabling themselves in-house?
Yeah, that's another good question. And there are many variations of ways that you can approach this. And you're right, it is, if you're coming from this castle and moat way of doing things, and you've got a lot of legacy infrastructure, it can look like a big change. And one of the things we definitely find people getting a lot of success with is you can bring in professional services teams, service integrators, other people to deploy stuff for you. But one thing we find works really well is the idea of, you don't necessarily want someone to come in and hand you a fish. You want someone to come in and teach you how to fish. So it could be that you hire people in to be the experts that then teach the rest of your organization, or you have support and training that teaches the people that are already there. But I mean, that's kind of a how long's a piece of string sort of answer to that question, to be honest. But yeah, generally the idea is, as Russ was saying, this is not a thing that you buy and then it's done. it's a workflow and mentality change, and really the way to do that is to skill your people up, teach your people how this new workflow is going to work.
Yeah, just to add something onto that. So one of the things I've seen work quite well, we talk about it if you search for crawl, walk, run type approach that we have here, because I think people would love that. I'm going to just do absolutely everything tomorrow and it's going to be brilliant. But let's be realistic. It's difficult to kind of do that. So one of the things I've seen work quite well. So I said that because this is a paradigm change, sometimes it's really just a case of getting that belief that it is possible. So what we've seen is people will not try and do everything at once, because that is difficult. They'll just try and do something simple. So if we can prove that we can take, an application through from development through to production, we have a kind of an automated workflow. It is secure. We have implemented zero trust for one application. Once people start to see that it is possible, they start to believe that the paradigm is possible. Then all of a sudden it becomes a lot easier because you've proved it with something simple and straightforward. Don't start with your hardest, most difficult thing. Some people think that is the way to do it. I guarantee you'll do the hardest, most difficult thing and you'll just be fighting your whole way to get through that process. Take something simple, prove that from start to finish, dev to production with this approach, prove it out, and then you can start to roll it out elsewhere, because once you've started to develop those patterns and the confidence in that.
Great, thank you both. On to the next question. Where does audit come into this zero trust presentation? Which HashiCorp tools are responsible for that?
Yeah, that's a good one. There isn't a single HashiCorp product that is the audit tool. And the reason for that is auditing who has done what and when is kind of a fundamental thing that you need to know for all of these. So all of the tools have built-in auditing functionality, which can be as simple as printing out audit logs to a file that you view later, or you can ship them off to a log platform or a seam or wherever and analyze them there. Yeah, there's no real this is the audit tool. It's sort of built in as a fundamental principle. And one of the good examples of this, actually, that I can think of, in Vault, the way we handle audits in Vault is if you enable auditing within Vault, then you want assurance that anything that happens within Vault is going to show up in the audit logs. And so if for whatever reason Vault cannot communicate with the audit tools or wherever it's shipping the audit logs off to, Vault will actually refuse to answer requests until you fix that. But yeah, it's the idea of you want to make sure you can look back and see who's done exactly what and when. It's sort of fundamental to how these things work.
Great, thank you, Lucy. And the last question we've got, Russ, perhaps one for you. If our company is quite far in our journey with a pretty well managed and secure AWS infrastructure, is there a benefit to considering HashiCorp tools, things like Vault, instead of the built-in cloud-native AWS ones that we're using now, for example, Secrets Manager?
Yeah, great question. So basically, you're operating in a single cloud provider. Does it make sense to use something like Vault? I would say it is, for a few different reasons. We had a customer told me it was a couple of years ago now that they operate in AWS, so a single cloud, but they operate in multiple different regions, for example. So there is, they've got things in Europe, they've got things in the US, they have some things deployed into China, for example. And one of the things that they deployed Vault because of the consistency of experience across all those different regions. Now, something that I didn't realize is that some regions inside of AWS have different capabilities than others. It's fairly uniform, but there are some cases where specific capability wasn't available. I think it was in China. There was some capabilities that weren't available there. But Vault was consistent wherever it was. So they got the same developer experience, whether it was in UK, US, China, Australia, wherever they'd actually deployed Vault to. The other thing that I had someone else who moved to Vault, and that was because if I was to talk about Vault sort of when it came out, I'd call it sort of a secrets management tool. I would call it a platform today. One of the principal engineers says, we've got to stop calling it a tool because it's a platform. And what I mean by that is, if I go and speak to 10 different Vault customers and say, what is Vault to you? They'll give me 10 different answers. It's not because they don't know what Vault is, it's because Vault has many different capabilities. So I want to use some Vault for secrets management. I need to store some secrets somewhere. Another popular use case for Vault will be for certificate management. Vault is our PKI infrastructure. For us, Vault is our data protection platform. I need to make sure all of my data is encrypted before I persist it anywhere. So all of a sudden, instead of having all of these disparate systems inside of the cloud that each have their own audit capability. So again, I was speaking to one customer, they were using like a key vault in the cloud. They had 800 of them, and security panicked because they were all configured differently. Auditing was set differently for them. Role-based access control was different for all of them. And all of a sudden they had this sort of secret sprawl, even within a single system inside of a single cloud provider. So yeah, so things like Vault absolutely can provide a consistent experience across multiple different use cases, a single audit trail, a single method for authentication, for example. And then also as well, on top of that, even if you're only using a single cloud today, I've spoken to people and they were like, we're only ever going to use AWS, for example, and then they make an acquisition or they merge with another company, or all of a sudden there's a change of management and there's a change of direction. All of a sudden they're in Azure and they're in Google as well. Now, the fact is, if you're using cloud-specific services, it's the portability doesn't exist. Whereas if they were using Vault, if that ever happens, and it happens quite regularly, it would seem, they can just almost lift and shift the same patterns, the same workflow that they're using for one cloud across multiple clouds. Or perhaps people are like, we're using Vault and we're using it in the cloud, but also we realize we want to apply that same common operating model to our on-prem environment as well. You can use Vault in both of those locations too. And that's not just true of Vault, of course. It's true of Terraform, Consul, Nomad, Waypoint. All the products that we kind of talked about is that consistency of experience across all different types of workloads, containers, VMs, physical machines for those people who are still using them, and there's still plenty of those. So yeah, awesome. Thank you. Good question.
Great. Thank you, Russ. And I think that's about all we have for the question. So a huge thanks to both Russ and to Lucy for your presentations today. And with that, we'll conclude today's webinar. So if you do want to learn more, then you can see those next steps on the screen now. And also just a reminder that this webinar was recorded, and we'll share that with you via email within the next 24 hours. So with that, I really hope you enjoyed today's session. Thank you so much for joining us, and we look forward to seeing you next time. Thanks, everyone.
Thank you, everyone. Take care now. Bye.